Hi everyone, this is Miss Thompson. We are going to talk about topic 1.1b, which is a quick reminder on the three different linear equation forms. So we already talked about slope-intercept form in 1.1a, but we will review that. And then we're going to introduce point-slope form, which is I think the most useful one we'll look at today. And we'll quickly talk about general form, which honestly isn't very useful, but sometimes shows up on silly tests, and so we need to be familiar with it. So to get started, slope-intercept form we talked about yesterday. Just as a quick review, slope-intercept form looks like this. Y equals mx plus b, where m is the slope and b is our y-intercept. And again, the y-intercept means the line will cross at the point 0b, across the y-axis. So if you are unfamiliar with how to graph these kinds of lines, I'm going to walk you through those steps. So we're going to look at the line y equals 2/3 x minus 3 and graph it here. To graph this, the first thing you're going to do is plot your 0b, your y-intercept. So in this equation, we can see that our b value is equal to -3. And so I know that I want to plot the point 0, -3. So I'll come over here, I'll go down 1, 2, 3, and I'll plot my point. And this is my y-intercept. The next thing we want to do is we want to use the slope to find another point. So our slope, as we can see from this equation, is 2/3. And so I'm going to write that again here. M is 2/3. And I like to remind myself that this is rise over run. So the up and the across. I'll then use my slope. I'll go 2 up and I'll go 3 across to help me identify a second point. This is about the point you can stop, but if you want to, you can find a third point by going backwards. So I can go backwards 3 and down 2, and I can find another point. And my last is just to connect. And so my line looks like this. All right, so we can also go backwards. So if we're given a graph, we can see this graph over here, we can come back and find the equation. So there are actually 3 steps. So I've got 1, 2, and I'm missing a third here, but we'll get it as we go. The first step is to identify the slope. So our first step when we want to write an equation for a line is to identify the slope. And so I'm going to do that using the equation that we had from our last lesson. And our equation was that the slope is equal to the difference in 2 different points. So we have y2 and x2 and y1 and x1. And so we need to have our 2 points. So I'll take this point 0, -4 as my x1, y1. So 0, -4. And my x2, y2, I'll take this point here, which is 4, -1. Now to find my slope, I can plug in my values. y2 is a -1. x2 is 4. y1 is -4. x1 is 0. And I'm going to be subtracting and dividing. To simplify this, I'm going to end up with m equals -1 minus -4, so plus 4, gets me +3 over 4 minus 0 is 4. So this is now my slope. M equals +3/4. The next thing is a little more straightforward, which is find your y-intercept. And so luckily, my y-intercept on this graph is shown here, the point where my line crosses the y-axis, and my y-intercept is the point 0, -4. This helps me know that my b value is equal to -4. And now my last step is to plug it in. And so my equation is going to be y equals mx plus b, as we saw before. We have mx plus b up here. My m is 3/4 times my x. And then instead of plus b, I'll do -4, so I'll drop that positive. And this will be the equation of my graph. All right. The next thing we're going to look at is point-slope form. This is another really useful one. Point-slope form is really good when you have a point and a slope, but not necessarily the y-intercept. And so point-slope looks like this. Point-slope is y minus, I'll use green, y1 is equal to m, which is still my slope, times x minus x1. And so like I said, we still have m is equal to our slope. And in this case, we also have the point x1 comma y1, which is just equal to any point on the line. Any point on the line at all. Doesn't have to be the y-intercept. So we can write an equation using this form if we have any point and if we have a slope. Sometimes you might have to find the slope because it's a longer problem or a word problem, but once you get to a point and a slope, we can write this equation. So to identify the equation, we'll start by plugging in our numbers. So we will find a point and identify it. And so here we're given our point is 2, 4. We'll also find our slope. And here we're given that our slope equals -2. And then we can plug it in. So what we're going to have is essentially y minus y1, which is 4, is equal to our slope, m, which is -2, times x minus x1, which is 2. And we actually leave it in this form. This is the form that we leave it in because we're not simplifying, because we're asking for point-slope form. If you wanted to, you could simplify this to get into slope-intercept form, but usually it will ask you to leave it here. So we can also use point-slope form to find the equation of a line from a graph. So to do that, it's pretty straightforward. Again, we need to identify the slope always. So I'm looking for what's the equation of this line over here. The first thing we need is a slope. I'm going to use just rise over, or the same equation we've been using previously. So we know that our slope is equal to, when we have 2 points, a y2 and an x2 and a y1 and an x1 subtracted from each other. And so we need to have 2 points. I'll take my x2, y2 to be this point, 3, 7. And then we have another point here, which is 5, -3. And now I can plug them into my formula. y2 is 7, x2 is 3, y1 is -3, x1 is 5, and I can simplify this to get 7 minus -3, which is 10, over 3 minus 5, which is -2. When I divide this, I get -5. And now I know my slope is -5. The nice thing about point slope is the only other thing I need is any point. And so we're going to use the point 3, 7, which is this point up here. Now I can plug. And so I'm going to use my point slope form that I've written at the top. And we can see we want y minus